Hi, I'm Jez, and welcome to this class on calculating sound file sizes. We've previously looked at an introduction to binary, but also we've looked at a previous class to do with calculating image file sizes. And the process we used, the method we used to calculate an image file size is pretty similar to how we're going to calculate sound file sizes. So let's begin. I'm going to share my whiteboard. Okay, and I'm just going to draw a quick graph. So we've got an X and Y axis. So why am I doing this, you ask? Well, when we speak and we hear our analog sound, it looks something like this. It's like a wave. Okay, so this is like a sound wave. Now, how do we convert that to digital and then finally work out how much storage or how big the file size is going to be? Well, there's a few elements at play here. Okay, the first is to do with sample rate. Okay, so if we look along our wave, okay, let's take this point. We're going to take a sample of that. We're going to record that sound at that particular moment in time. Okay, and then we're going to take another one. Maybe it's here. And we're going to take another one, and another one, and another one, and so on and so forth. So along our sound wave, we are taking a sample, recording what that sound is like at that particular moment in time. And this is what we call the sample rate. Okay, the sample rate, the rate at which we take samples, usually measured in hertz. How many samples per second? And I think the standard is like 44,000 samples a second. Okay, so it's usually measured in hertz, but basically it's how many of these samples we collect per second. Okay, the more samples we take, the more sound we record. So we get a better overview of the overall sound. Okay, but if we were to join these dots up, can you see with straight lines? I use my straight line drawing tool. There we go, like so. Okay, it sort of follows. It sort of follows the wave, but not quite, doesn't it? If we were to add in more samples, like we'll double the amount of samples we take along that wave and we join them up, we would get a smoother curve, wouldn't we? That more closely resembles that sound wave. Okay, so it'll be a more truer, more accurate recording of that sound if we're sampling more. Now, in our previous lesson, when we were talking about color depth per pixel, that is the amount of information each pixel in our image can store. It's the same in this case with sample, and we call it the bit depth. Okay, so each sample obviously is going to store information about that sound at that particular time, and that's what we call the bit depth. So already we are introducing ourselves to a few key terms here. So we've done sample rate. Okay, and now we are doing bit rate, bit depth. Bit depth. Okay, so bit depth is the amount of information it could store. So again, this is where our introductory to binary class comes in. Remember that table? We could have a bit depth of maybe 2 bits, or 4 bits, or 8. Usually you're looking about 8 or 16 bits per sample. You can increase it even more, but as we step through the calculating process, you will soon realize that if we increase ever so slightly, if we increase the number of samples and also increase the bit depth per sample, then our overall file size grows quite a bit and grows quite quickly too. Okay, the final thing we're going to need is time. Okay, and this is measured in seconds. Okay, so the time, we also need to know the time, how long our sound sample is. Now, at this point, I always tell my students to reread the question. Reread the question because sometimes they give you the time in minutes, and we need the time in seconds to be able to do the calculation. The amount of times I've seen pupils go through the calculation correctly using the correct process, but they use the minute value instead of the second value, and it's heartbreaking to see. So whenever you're ready, you've got all your elements in place to do the calculation, reread the question just to make sure that they haven't given you the time in minutes. If they have given you the time in minutes, do a quick conversion into seconds and bang, you're ready to go. Okay, so the important thing to remember is time is always presented, needs to be presented in seconds when we're calculating. So how do we calculate? Well, we take those three elements and we just times them together. So we might have a sample rate of 44,000 samples per second with a bit depth of say 16 bits. So as you can see, I'm timesing them, and we're going to times it by the number of seconds. So it's a 2-minute sample that we've got. I take the minute value and I convert it into seconds, so it's times 120 seconds. Okay, very, very similar process to calculating image size. And again, that will give you your answer in bits. And so the same advice still stands. Once you've got your answer, just double check the question just to make sure that they haven't asked for your answer to be in megabytes. If they have, use the same conversion process that we went through in the previous class when we were doing image file size. Okay, so you take your bits, your answer in bits, and you start then to convert through those units of measure to get to the one that they've asked for, usually in megabytes. So you go from bits to bytes, bytes to kilobytes, kilobytes to megabytes. Okay, so let's just recap on what we've covered in this class and previous classes. We've done an introductory into binary. We've learned how to convert both ways. We then went on to learn how we calculate the image file size and learned a bit more how pixels are used to represent different colors and how much information they can store per pixel. And we've gone on to sound files as well, learning a bit of how we digitize analog sound and keywords such as sample rate, bit depth, and time in seconds. Okay, so I would advise you to just pluck some typical sample values, okay, and start experimenting with different bit depths to see how if you tweak one factor, one element of this equation, what effect does it have on the overall file size result, and which element affects the file size the most. That's a really interesting one. See, if you're up for a challenge, try and work out which element in this equation affects file size, has the biggest impact on the overall file size. And we'll leave it there. I hope you found this useful. Thank you very much.